This is Christian Root Bowman. I'm the PLF for Gen Chem 1, Fall 2019 semester. I'm going to be working the bonus question from Review Quiz 1, which we did last week. Mercury poisoning is a disease that's often fatal if the amount of mercury in a polluted lake is 0.4 micrograms per milliliter. What is the total mass in kilograms of mercury in the lake? So with difficult word problems like these, or really any difficult problem in chemistry, I like to break the problem down before starting to try to tackle it. I like to ask what sort of problem it is. Have I seen these kinds of problems before? What's it really asking? What should I be really solving for? My knowns, my unknowns. I like to make a plan to solve the problem, work that plan, and then I like to go back and ask myself if my answer makes sense and if it ultimately answers the question. So let's get into this. What kind of problem is it? Looking back at the problem, it's asking me to take units of micrograms in a ratio to milliliters, find some kilograms, and it gives me some values of surface area and depth that I'm supposed to try to find volume with. So it's clear that there's going to be a lot of unit conversion, there's going to be some usage of ratios. In other words, this is a dimensional analysis problem. We've seen a lot of these problems in this unit. We're continuing to work these kinds of problems with stoichiometry now, and it'll be important to obtain some level of mastery with dimensional analysis going forward in general chemistry. So what's the problem really asking? Well, it turns out this is pretty straightforward. All I need to do is find the total mass of mercury and make sure that the units are kilograms. So I'm solving for a total mass of mercury in the lake. Well, let's figure out what I know and what I don't know. So I know this ratio of 0.4 micrograms of mercury per milliliter of lake water. I know what the surface area of the lake is in square miles. I know the depth of the lake on average in feet. And then I'm given a couple of conversion factors. I'll probably also need to either know or look up a couple of additional conversion factors. So I've written that out. The two big unknowns are the volume of the lake. I'm going to need to figure out the total volume so I can make use of my ratio of 0.4 micrograms to milliliters. And then I'll need to eventually end up with the total amount in kilograms of mercury. All right, so let's make a plan to solve this. Step one, I'm going to try to find that volume. Basically, all I need to do is multiply depth by surface area, but I need to have some consistent workable units. So my plan, personally, is to go from square miles to square kilometers to square meters. I can convert the feet to meters as well. That'll eventually give me cubic meters, and I can convert cubic meters to liters, which is a unit of volume, relatively easily. Once I have liters, I can convert that to milliliters. I can make use of the ratio I was given to find the total amount of mercury in micrograms, and finally I can convert that to kilograms, which should be my final answer. So it's a lot of unit conversions. It's going to get a little tricky, but I've got a pretty good plan, I think. So let's go ahead and start working that plan. Okay, so I'm going to go ahead and take my square miles, and let's just convert that into kilometers. So I'll take the conversion factor that I was given and just plug that in, right? No, not correct. You'll notice the units here will not cancel. Square miles will not cancel with miles. So what do we need to do with that conversion factor to make it appropriate? We need to take the entire conversion factor and square it. That'll give us this new value of 2.589 kilometers squared over miles squared, which will be an appropriate conversion factor. You'll see this come up again in this problem where we have to square or even cube our conversion factors to make it work. All right, so now that we've done that, I'm going to go ahead and plug it in. I'm also going to go ahead and just convert kilometers squared to meters squared. You'll notice in that conversion factor, normally it would be 1 kilometer to 1,000 meters, but I've gone ahead and squared that conversion factor to make it appropriate as well. So it's now actually 1 kilometer squared is equivalent to 1,000 squared meters squared. It's a much bigger number. So doing some math, I'm going to see my miles squared units cancel, my kilometer squared units cancel, and I'm left with this value of 2.6 times 10 to the 8th meters squared. That's still just the surface area of my lake. Now I can convert my average depth to meters pretty easily just using the given conversion factor. And you'll notice now we're all in meters. We've got meters squared times meters. That's going to give us this volume ratio. The new unit is cubic meters. I'm going to go ahead and take that volume and convert it to liters. So 1 cubic meter is equivalent to 1,000 liters. And that'll give me this new value, 1.6 times 10 to the 12th liters for volume of the lake. Let's go ahead and just pause right there and ask ourselves, does this answer make sense? And I'm going to go ahead and say that it does. If you look at some other fairly large lakes, say Elephant Butte or Navajo Lake, this is actually a little smaller than them, and that makes sense. Even though we've got a pretty big surface area, 100 square miles is pretty sizable, it's relatively shallow. It's only about 20 feet deep. So I think that this answer does make sense and will serve us well going forward. Of it. Now that we've got our volume measurement, let's go ahead and just convert that to milliliters really quick. You see our number is going to get bigger. Units of liters are going to cancel. Obviously, there's more milliliters than there are liters. So now I've got the total volume of the lake in milliliters. I can go ahead and now use the ratio that I was given in the problem of 0.4 micrograms per milliliter of lake water to determine the total amount of mass of mercury in the lake. Some students might stop here. They might say like, okay, I've got the total mass, I'm done. But recall that we're supposed to be finding the mass in total in units of kilograms, not micrograms. So let's go ahead and convert that real quick. You'll notice I just used this one big conversion factor of 1 times 10 to the 9th micrograms per kilogram. If you're not comfortable doing that, you can break it down. You can do micrograms to grams, then grams to kilograms. You should end up with the same answer though. So eventually I end up with this calculation of 6.4 times 10 to the 5th kilograms of mercury in this lake. It's a pretty big number. That's a lot of mercury in the lake. It seems reasonable considering our volume calculation though. So I think that if we go ahead and plug that in for our solving and ask ourselves, does it make sense? Yeah, I think that it does make sense, even though it's a really big number. Going back to the original problem, I also think we've answered the question. It was asking for the total mass in kilograms, which is exactly what we've found. You may find that your answer differs somewhat from mine. It depends on how you do rounding. I did some intermediate rounding, not a ton. You might have done more or even less. It could definitely change the value of your answer, but it should be somewhere around my answer, especially in terms of 10 to the 5th kilograms. I hope this has been useful for you. I hope that you'll take some strategies for problem solving away from this. I think they can be applied to almost any complicated chemistry problem, and that you've also found this a useful review of dimensional analysis. Thank you.